Welcome to The Explainer. Okay, today we are breaking down an absolutely massive shift happening right now in software engineering. We're looking at the recent boom in AI coding. And, to really make sense of this sweeping industry transformation, we're going to use a real-world, highly complex compiler rewrite as our starting point. Let's just get right into it.
Okay, let's dive into this. Here is our roadmap, going from the micro right to the macro. We'll start with the Roc compiler rewrite, then look at the evolution of AI agents, tackle the beginner-developer paradox, explore the rise of Slopware, and finally, wrap up with trust as the new standard.
All right, Section 1, the Roc compiler rewrite.
So to give you a little context here, Roc is this purely functional Elm-like language. It's designed for simplicity and just incredible performance outside the browser. But here is where the story gets really compelling. In February 2025, the community decided to rewrite their entire compiler, moving from the Rust programming language over to Zig. And this massive architectural shift, it began at the exact moment AI coding agents truly started to take off and really infiltrate the developer workflow.
I want to walk you through this wild one-year ride, because look at how fast this moved. In February 2025, they start with a blank text file. By March 2025, they're using early models like Opus 4.1. Fast forward to November, and we hit the Opus 4.5 era. Then, by March 2026, developers are utilizing GPT 5.4, and the new compiler is actually nearing feature parity. It's crazy. The underlying AI models were evolving at an absolutely breakneck pace, right alongside the compiler's actual progress.
Moving on to Section 2, evolution of AI agents.
Now, what's really interesting about this slide is the stark contrast in utility over just 12 months. I mean, think about it. Back in March 2025, AI was essentially just a mechanical code generator. A developer would use it to mechanically port over existing Rust tests into Zig. Helpful for rote tasks, sure, but by March 2026, the AI had become a fully interactive architectural partner. Instead of just mindlessly porting code, developers are having deep back-and-forth debates with the agent. They're asking it to diagnose complex problems, explore the code base, and even predict what would break if they implemented a whole new architecture. It's a huge leap.
Which brings us to Section 3, the beginner-developer paradox.
And this brings us to a really unexpected challenge. The beginner paradox. Because while experts are getting this huge leverage, the simple mechanical bugs that junior developers traditionally used to learn codebases are just gone. Think about it. In the past, if an error message had a typo or was missing some context, a beginner would jump in, figure out the build system, maybe break a few tests, and actually learn how the architecture functioned. But today, you just tell the AI to fix the typo. It's fixed instantly, but the beginner learned absolutely nothing about the inner workings of the project.
Developer educator Anjana Vakil captures this perfectly. She asks, how do you learn to run before you can walk because you're not encouraged to walk anymore? Because why would you walk when there's a robot that will just zip you down the street? Man, it's such a brilliant, powerful metaphor. That friction, the friction that used to literally force us to learn the fundamentals, is being entirely smoothed over. So I pose this directly to you. If the AI does all the walking, how do new contributors actually learn a codebase? Open source projects like Roc are currently struggling with this exact question. They are finding it incredibly difficult to find brand new contributors who can just jump in and make a meaningful impact without needing, massive amounts of handholding from the project leads.
The reality is that the way we learn is shifting dramatically. The old way, making those minor syntax-level code contributions to learn a system, it's fading. The new way? Well, it's looking a lot more like napkin drawing in a coffee shop. Learning is shifting away from memorizing language-specific syntax and moving heavily toward high-level, foundational reasoning. It's all about first principles abstractions and understanding system design from a bird's-eye view.
All right, Section 4, the rise of Slopware.
10x to 100x. You literally see these numbers everywhere online right now. Developers are claiming these massive productivity boosts, boasting that they're outputting code at 10 to 100 times their normal speed.
So the crucial point is this glaring disconnect. End users, the actual people opening these apps on their phones and computers, are absolutely not experiencing 100x better software. They aren't saying, wow, this is updating constantly and the quality is pristine. No way. Instead, they're experiencing buggier, slower, and way more frustrating software. There is a massive mismatch between developer inputs and end user outputs.
We are entering a whole new era, and it's called Slopware.
It's defined as low-effort, bug-ridden applications, endless overnight clones, and spam pull requests that are generated effortlessly by AI. When generating a syntactically valid but fundamentally flawed app takes zero human effort, the market gets flooded with exactly this: low-quality noise.
But open source projects are already deploying an immune response to this flood of AI spam. Look at how different communities are defending themselves right now. The terminal emulator project Ghosty was so inundated with low-effort pull requests that they implemented a vouch system. Like, you literally have to go into their chat and get a real human to vouch for you before you could even contribute. The Zig programming language went the other way, a strict, zero-tolerance, no AI policy, and they even migrated their repository to Codeberg just to escape the noise. Meanwhile, projects like the Zed code editor are leaning on their inherent focus on high-performance, Rust-based quality to naturally attract a contributor base that just shuns Slopware entirely.
Which takes us to our final section, Section 5, Trust as the New Standard.
Let's move to and see how this builds, because to fight back, developers are having to adopt super rigorous automated testing. First up, fuzzing techniques to catch weird edge cases by basically throwing massive amounts of random data at a program. Next, property-based testing to ensure broad rules always hold true across the entire system. And finally, encoding strict invariants directly into the code. You see, you can no longer just leave text instructions in a prompt. The architecture itself literally must automatically reject bad AI logic.
Here is the ultimate takeaway for anyone building software right now. In a sea of endless AI clones and bug-ridden slopware, human trust and uncompromising quality become your absolute ultimate differentiators. I mean, when absolutely anyone can generate an application instantly, building a high-trust, frustration-free tool becomes your most valuable competitive advantage. Users will naturally migrate to the tools that simply do not break.
I want to conclude this explainer by leaving you with this final, provocative thought. In a world awash in AI slop, will uncompromising human quality be your competitive edge? It takes more effort, for sure. It takes more rigorous testing and much deeper foundational knowledge, but it might just be the only way to stand out. Thank you so much for engaging with this structured breakdown. Keep learning, keep pushing for quality, and we'll see you in the next one.